And here we are moving from smart analysis to more autonomous action. So, Agent Core Bedrock bridges the gap by letting you safely run AI agent that can investigate security issues with full context, decide on appropriate responses based on policies, act autonomously to remediate threats. All of that is built based on a lot of security features that are provided by Agent Core. So agent core provides in general the identity. We're talking about GW tokens that are efficient to be used for authentication with custom scopes. Talking about isolation, tenant separation, and secure execution environment. We are talking about auditing, and here it is a full cloud trail that can be used for logging and for every agent action. Finally, the governance. It is a fine-grained access controls and policy enforcement. Agent Core, it is what make AI automation acceptable to security teams. I would say it is what helps us to act and to behave like security teams. It is not just one agent, it is multiple agents. All of them can interact together, investigate in order to make the right actions. Okay, so Amazon Bedrock Agent Core, it is a comprehensive agentic platform that gives us everything we need to get agents into production securely. Here we are talking about 9 integrated components. Starting on the left, we have runtime. It is used for the execution engine that runs your agent. Talking about the memory, that provides more persistent context to agent. So the agent can learn across sessions. Then we have the identity that handles the different token, the access token, I would say, based on the authentication with custom scopes. Then moving to the gateway that serves as the entry point with model context protocol to the MCP support. We'll talk about this in just the next few slides. Then you have the code interpreter that will allows agent to execute code safely in isolated environment. Then we have the browser. This will help to enable the web interaction when it is needed. And then what do we have? We have the observability, and it gives you a full visibility through the integration for your agents. And then you have the policies, and the policies, it helps to provide a more fine-grained access control and decision boundaries, what to do, what not to do. And then we have the evaluation. Evaluation is just recently added, and it will provide for you to continuously measure your agent's performance and accuracy. And this isn't just a collection of tools. It is integrated platform designed specifically for agent in production in a secure workload. So I would say for production security workloads and for any other workloads that you see, it is important to see many agents interacting together. Talking here about 3 operational pillars. The first one, it is building agents with tools and memory. The second pillar, it is mainly deploying securely the agents at a scale. And for the first one, we will see the gateway, memory, browser, and code interpreter. Mainly, they are the main actors when we would like to build agents with tools and memory. For the second one, deploying securely at scale, it's the most important component that are the runtime, identity, and policy. And finally, the third pillar, it is gaining insight into agentic operation. And here we are talking about observability and evaluation. So Agent Core supports the framework you are already using, like Strands Agent Framework, Crew AI, OpenAI Agent SDK, Cloud Agent SDK. So you are not locked into a priority approach. The most important to take in consideration is your data set, your business logic, and what goal are you looking to achieve through adopting this platform. So quickly here, just to give you an overview about how this Agent Core platform architecture workflow is working in practice. Here we are talking about the runtime that stores and retrieves the agent state and context from memory across sessions. There. And then the runtime sends the tool invocation request to the gateway. The gateway returns the tool execution results back to the runtime. Then we have the gateway that is supposed to enforce identity and policy checks before allowing the tool execution. We have the gateway also, which is responsible on authenticating every tool request through identity and enforcing also the governance rules through the policy before execution. The gateway also has two other main rules and interaction with the browser and the code interpreter. Sorry, it routes web interaction request to browser. It routes code execution request to code interpreter, mainly in isolated environment. Finally, we have the most important one, as I have mentioned, observability and evaluation that are supposed to interact together. Every component send a telemetry to observability, and the observability is responsible on capturing all agent action, decision, and tool invocation. The data flows from the observability component will be sent to evaluation for a more continuous performance and I would say security policy insurance.
Miriam, just a
Yeah,
reminder, we have 5 minutes
yeah.
in your section before a much needed break and a demo.
Yeah, I'm almost done. So here I would like to give an example about the how to use Bedrock Agent Core, which is used for the intelligent WAF log analysis and automated thread responses. Here we are talking about sorry, the challenge here is that modern AWS environment is supposed to generate massive volume, and we have discussed about that already, like data from the cloud from CloudTrail, GuardDuty, and VPC flows, and how I would say Bedrock Agent Core helps. It helps by providing a smart pattern recognition across millions of log entries, correlating them, and then making the differences between the false positive and the true positive, and then providing more autonomous actions like downloading CloudWatch, creating IP sets with malicious addresses, updating the WAF, and making the needed actions directly without referring to the security teams. But security teams, they keep absolutely track over that. So, what do we have here? Here we have the architecture, and I can start with the right side. We have two specialized runtime agents that are working in sequences. The first agent, core runtime agent, I would say, is downloads the logs from the CloudWatch and runs a comprehensive analysis. Then we have the second one takes autonomous actions based on that analysis. It downloads the current WAF configuration, creates IP set containing the malicious addresses, and automatically attaches those IP set to your WAF, updating the security posture in real time. So at the bottom here we have our security engineer who is able to invoke the application, but here it is what is critical. The engineer doesn't need to manually analyze the logs, identify threats, and update the rules. Why? Because the agent core agents were able to handle all of that autonomously without referring to the security engineer. The most important key point here it is the power of the system. It is mainly the closed loop. These threat actors, they generate malicious traffic. Yes, the WAF log captured it, CloudWatch aggregates it, and the agent core agents analyze them in real time, making the analysis, taking the decision, updating the WAF rules, and going forward. So it is like a loop, efficient way. The agent it keep learning from the previous experience, so it is adapting in efficient way the future decision. So this is an example. Also, we have prepared another example, but because lack of time, so here we have the cloud trail log analysis, and also it is the same philosophy, if I can say, and it shows how are we using the different agentic AI in order to enhance the analysis and taking the decision without referring or would say without any kind of manual work. Same thing here also for more unified security analysis, but in this example, it is a full picture. We took AWS CloudTrail, VPC flow logs, and AWS WAF resolver DNS also. We sent all this data to our AWS MCP server. I'm going to just to give you just a quick information about MCP and then it's done. All of them, they will be sent to our agents for analysis and then making the right retrieval, correlating all of them together. So we will take in consideration what is configured, what is working from the different layer of our protocol stack for our application, then taking the decision and then moving forward with a continuous monitoring and a continuous security accurate feedback. So, because I cannot close this meeting without mentioning the MCP server and why they are important. So, the MCP, it is the model context protocol. It acts as our universal connector, enabling agent core agent to easily access multiple security services without needing custom integration for each tool. Why it is important? Because this will help you to orchestrate the different tools that your agent will need to interact with. I would say it is a way that we use in order to be sure that our different tools used by our agent that are secure, authenticated, and authorized. I enjoy all the time saying MCP turns AI can do anything into AI can do what we explicitly allow it. And here it is an example how it can work the WAF and the agent without MCP and how our agent they may work with the MCP and how we can move from a nightmare security to a very explicit permission model. I'm giving also by the last slide the before MCP, every AI tool needs custom integration. Each LLM vendor has different API. And after the MCP, we can write once, use with any MCP compatible LLM. We are talking about secure, controllable access to enterprise data, and the most important, and this is, I would say, the recommendation, reusable MCP server. It can be done across many applications. One thing to close this session, we have MCP proxy that is already from AWS. It is already right now generally available and it can be adopted. Finally, it is this full picture optimized architecture, including everything, the different tools that from where we can gather information, guard duty, AWS, Cloud Trail, VPC Flow, WAF, and then also we have integrated MCP, so it will provide for us the right orchestration for our different tools. Our agent from agent core bedrock, so will help us to make autonomous and dynamic action to our security teams. And here we are, final slide. I would like to say there are 3 things to keep in mind. Amazon Bedrock is the different models that they can be used for smart security rezoning. I enjoy all the time saying that models and Amazon Bedrock, they are the brain. Then Amazon Bedrock Agent Core, though they are used for autonomous security orchestration, and here it is the body for your security operations. Finally, we have the MCP. MCP, it is like the nervous system. You are controlling everything, agents, their tools, how they are interacting. Yeah, and right now I'm going to give it to Mark for the demo.
We're going to take a 5-minute break right now.